Hello everyone, this is V. Manikyala Rao, working as Assistant Professor in the Department of CSC ANML in BVRIT Narsapur. So now today we want to discuss about classification and prediction. So these are the different topics are available in the classification and prediction. So I will explain one by one. Now coming to the first one, what is classification and what is prediction? Classification means it contains only categorical values. So categorical values means, let us assume that we have to take the example for categorical values, gender. So gender contains only male, female and other. That is within that category only we have to use and classify that one. So the particular person name, for example, I given the name as Hari. So this person belongs to male. Within that gender category only we have to divide. That one is called it as classification. So now coming to the next one, prediction. Prediction means it is a continuous value, just like we have to take house rent or we have to take income or age based on the date of birth. So that will be continuously increased. That is called it as prediction. That's why I taken the example for house price. Continuously that value will be increased based on that situation. Now coming to this one, in the types of problems what we have to use, image recognition and the diagnosis and sentiment analysis. So image recognition means, for example, if they are given the image, so that image is having happy, or if the image is having anger face, or if the image is having any bad face. So within that particular categories only we have to divide and implement that particular classifications. So here we are using forecast and continuous value. That means the stock prices. So those all are continuously increased based on that situation, and that day that value will be varied from one to another. So here we are using decision trees, SVM, support vector machine, k-nearest neighbor algorithm. These all are the different algorithms we are using. So by using these algorithms, we need to classify that it belongs to the particular category or not. Here we are using regression trees. So regression means it contains the independent variables and dependent variables. Independent and dependent variables. So our equation for the linear regression is y equal to mx plus c. So x is our independent variable, y is dependent variable. When we are changing the value of x, that y value is also changed. So like that we have to describe all the regressions in the prediction part. So here accuracy, precision and recall. So actually accuracy means the total number of positives by positives plus negatives. Here precision means total number of positives by only positives plus false positives. True positives plus false positives, only positives. Recalls means same as it is, total number of positives by true positives plus false negatives. F1 score means the precision. F1 score is equal to precision by recall, 2 into. That is F1 score. Confusion matrix means it contains true positives, true negatives, false positives and false negatives. That is called as confusion matrix. So mean absolute error, mean square error means it is used to find out the errors based on the information that is to be found in the given linear regression concepts. So now coming to the example application, error detection, fraud detection, these all are the different methods here, and these are the sales forecasting. So these mainly this classification belongs to classify those all the values are to be there in the particular categories. Within that category we have to choose. Prediction means it is used to find out that is a continuous value. Day by day that value will be increased continuously based on the example for prediction means house rent or income or any salary or age based on the date of birth. Continuously that value will be increased based on the particular situation. That is called as classification and prediction. Now what are the issues we are faced in the classification and prediction means, for example, if they are given some data, so in the data is having any missing values or any noisy values or any inconsistent values are there, that type of values we need to be overcome by using these concepts of data cleaning. So now see here, they are given the data set like this data, this row is having all the data and this row is also having all the data, but here we are having some missing value, this value is missing, we don't know the value of this question marks. So we need to replace that value with the mean value. So that mean value is 37.5. So this age is 37.5 like this. We have to place. So that missing value we need to write here. So the averages of divided by 5 plus 15 plus 50 plus 80 divided by 4. So that is equal to 37.5. So we need to get that value, that missing value like this. So this type of things we need to be removed by using the concept of data cleaning. The missing values will be removed. Relevance check means whether the given values are relevant or not. See here. So actually this normal is 0 and this one 0.14 and this is 0.44, 0.63 and 1.00. In case based on the given generalized category adult, so adult is having 20 to 59 years. So based on that we need to divide this age. We have to replace that one with the exact value based on the considerance of the given ranges they are to be given in the normalized ages. That is relevance check. And the last one, data reduction. So data reduction means it is used to having two types, normalization and generalization. Normalization means they need to reduce unnecessary values from the given data set, whether the given relevance, for example, the given item row, this row is not relevant to this and we don't want to replace, we don't want to display the particular row, means when you use normalization. Generalization means based on the categories and the particular ages belongs to. So 0 ages belongs to what, based on that generalization. Within that 4 ranges only we have to divide the generalized categories for this from the particular range. That is the issue is to be happened in classification and regression. By using these, all are call it as data pre-processing techniques. By using data pre-processing, we need to remove that type of issues in classification and prediction. So we have to use data pre-processing techniques. That is, this data cleaning is one of the type of data pre-processing technique. Now, how to divide that classification by using decision tree? So decision tree contains, actually we are having 3 types of things. This is our root node and these are the child nodes. This is a left child node and right child node. Particular right child node. So based on that, this particular left child, they are having left side node and the right side node. The leaf nodes is to be generated like this. So if we have to classify the decision tree by using what algorithm, means we are having one algorithm, that is ID3 algorithm. So this by using this ID3 algorithm, we have to create the decision trees by using the classification techniques, classification concept. So now here, if you have to implement ID3 algorithm, the full form for ID3 algorithm means iterative dichotomizer 3. So iterative means continuously, repeatedly the process will be going on. Dichotomizer means splitting. So splitting each and everything into parts. Then 3 means, actually we are having tree means 3 types things: root node, leaf, right, left child, right child. That's why we are calling 3. So by using this ID3 algorithm, we will implement the decision trees. The first step means, first we have to create the root node. How we have to create the root node means, the steps we have to follow means, first we have to calculate the information gain for total data set. So whatever the data set they are provided, we have to calculate the information gain for total data set. So that form minus p by p plus n. P means number of positives. P means number of positives. N means number of negatives in the entire data set. That we have to substitute into this equation to get the value of information gain between positives and negatives for the entire data set. Next, the next step means we need to calculate for each and every attribute. That means for each and every attribute type, we need to calculate the information gain for attribute. Here also P means number of positives, N means number of negatives. Then after calculating that one, calculate the entropy for current attribute. Whatever the attribute we are taken, for that attribute calculate the entropy of A. So sigma I equal to V PA plus NI. PA plus NI, for example, sky, the types are sunny and rainy. These are the 2 types they are having. PA plus NI means sky with respect to sunny, probability of sunny plus probability negative with respect to sunny divided by P plus N. Like this we need to write the formula. The types of this is the attribute, whatever we are using, that attribute, these are the types. This is called it as PA plus NI. By P plus N means that is from data set. Then we have to calculate the gain. So calculate gain means information gain for the attribute minus entropy of the attribute. Based on the gain value, if the gain value is the highest value, consider that as a root node. Then we have to do the process until the last 3 step is to be reached for this. So now I taken one example. Based on that I will explain one by one. So now I taken this example. It contains total 10 rows. They are having the attributes are age, competition and type. These are the attributes, and the profit is our status, whatever I given. So here we are having the 5 downs, this is a negative status, and the 5 ups, this is a positive status. Now, so information gain for total data set means minus 5 positives or 5 negatives are to be there, and for entire data set information gain we need to calculate, then we are getting the value for total data set is 1. Now the next step means we have to calculate the information gain for into each and individual attribute, that means for age, for a computation and for type. So now for information gain for the first attribute age we need to calculate. So information gain means that is minus p by p plus n. So that means old with positives is 0. So 0 by 0 plus 3 into log 2 of 0 by 0 plus 3. Similarly, all the values we are substituting from this table, we got the information gains for this. Then we need to calculate the entropy for this. So entropy Pa plus Ni means 0 plus 3 by 5 plus 5 into that information gain value 0. Then 2 plus 2 divided by total 5 plus 5 into information gain value 1. Next 3 plus 0 divided by 5 plus 5 entire data set positives and negatives into this information gain value 0. Finally, we got that value as 0.4. So next we need to calculate the gain. So that means this information gain minus entropy of age. So information gain value what we got? We get the information gain values for this one is 1 minus 0.0, 0.6, that is entropy for this one. So finally we got the gain for the age is 0.6. Now similarly we need to calculate the information gain for next attribute competition. So competition means competition type, so that positives and negatives. Competition is having two types, that is yes and no. Two types are to be there, and based on that we are calculating information gain for this. So we are getting the information gains 0.81, 0.91 by substituting into the formula, minus 1 by 1 plus 3 into log 2 of 1 by 1 plus 3 minus 3 by 1 plus 3 into log 2 of 3 by 1 plus 3, that is 0.81 for S. And similarly same 4 and 2 we have to use, divided by 3 log 2 into 4 by 4 plus 2. After that we have to get the value, this is for no. So then we have to substitute this one into the entropy formulas. Finally we got that one 0.8754 entropy. So information gain, so that value is 1 from the entire data set minus 0.8754, so that value is 0.12 gain for the competition. Now similarly we need to calculate the gain for type, same as this we have to do, and then we are getting the information gains for these two is 1, and finally our entropy value is 1. So finally 1 minus 1, that value is 0. So gain for type. So based on these values, gain for age is 0.6, gain for competition is 0.12, gain for type is 0. Out of these three values, whatever the gain is having highest value, that is considered as our root node. Now 0.6.20, so this is our highest value, so consider this as our root node. Then so age we are already know, age is having three types, old age, middle age and new age. Now coming to one by one, for this one you have to solve, and for this one you have to solve, and for this one you have to solve. So coming to old age, so they are having the same type of profit, so those all are negative profit, that's why you have to write directly, that is down. Next we will go to middle age, new age. So new age is also having the same type of positive status, that is same, so that's why I written up status directly to the new. Now coming to the third one, middle age. Middle age contains 2 negatives and 2 positives. So now we have to calculate for the middle age. The same process, the same step we have to take as the decision tree, the particular data set, and where for this data set we have to calculate. Now, so at the age of middle ages, competitions these are and types these are, we need to do the same process. So now the information gain for total data set means it contains total 2 negatives and total 2 positives have to be there. And those are we are calculating. Final information gain for this data set is 1. Similarly, we need to calculate the information gain for entropy of the each attributes. Now we are having the age, next one is we have to calculate that entropy value we are getting as 0 based on these two values, substituted into this one based on these two, we are getting the information gain for I of p common 0 and this one 0 first, no. After calculating these two things, entropy, we are calculating the gain for competition is 1. Then similarly, we need to calculate the information gain for type attribute. Same process we have to do. By applying those values, we are getting this value 1 and this value 1. By entropy, we are calculating, so that value is 1. So these all are from the data set. So this 1 plus 1 divided by entire data set, 2 positives and 2 negatives. Similarly, the same thing is doing. So the gain for type is 0. So based on these 3 gain values, next node we have to find out. So gain of computation is 1, gain of type is 0. So that's why the middle way is value. Out of these two values, this one is a higher one. The middle will be put into computation. Next, we need to find out computation is also having 2 types, yes and no. Now we will do the same thing. So if the computation is yes, they are having 2 same statuses down. If the computation is no, they are having 2 statuses same. So yes means down, no means up. So finally, this is about the final decision tree. Now here, this is the root node. These all are child nodes, and these all are sub-child nodes. Like this, we have to frame based on the given algorithm of ID3. This is about the classification of decision tree algorithm. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.